Okay, these notes are showing you how to find a limit from a graph. So we're going to determine limits graphically. But just to review, a limit can be determined numerically, analytically, and graphically. When I'm looking at this graph, this limit fails to exist wherever there's a vertical asymptote. So at x equals -1 and x equals 1, the limit fails to exist. A limit will also fail to exist at any place where the function jumps from one area to another. So here it's approaching 1 and then jumps up here till it starts going towards 2. So where this jump is occurring, there is also no limit. And the last time a limit fails to exist is when a function's oscillating. So this function's coming along here, but as I get closer and closer to 0, it starts oscillating back and forth. Same thing as it's going away from 0, and then it slows down its oscillation. So here at 0, the limit fails to exist. So when I'm looking at this graph here, I'm going to determine the limit and compare it to function values along the way. So I have got, first of all, when you look at graphs, make sure you're looking at the scale. This is counting by 2. So if this is -2 here, this is going to be -1. If this is 1, this is going to be 0.5. So be careful as you're doing this. The first limit I want to look at is the limit as x approaches -2. And I don't know the function equation. I don't even need to get it. So the limit as x approaches -2 of f of x. Here's -2 here. So as the limit is getting close to -2, remember this is counted by 2, this is going to be -1. Same thing from this direction. So I'm looking at it from the left and looking at it from the right. So the limit as x approaches -2 of this function is going to equal -1. But if I looked at f of -2, f of -2 is at -1. That's a hole there. F of -2 comes down to here. So if this is -1, this is -2, this is -3. So f of -2 equals -3. If I looked at, and I'm trying to find good points where they cross intersections on the coordinate plane, let's look at what happens at 0. So the limit as x approaches 0 of this function, as I'm coming from the left, the y value is getting close to a 0. As I'm coming from the right, the y value is getting close to a 0. So this limit as x approaches 0 of this function is 0. Same thing is f of 0 equals 0. So even though the limit wasn't the same as the function value here, it is the same here. That's a special case. The next one I want to look at is as I'm getting close to 1. So here's my 1, here's my function. The limit as x approaches 1, looks like the y value is getting close to 3. Same from the left and same from the right. So the limit as x approaches 1 of this function is equal to 3. And same thing, if I had x equals 1 and I go to the function, I find the y value is 3. So f of 1 equals 3. The next integer I want to look at is actually 3, right here at 3, x equals 3. So the limit as x approaches 3 of f of x. As x approaches 3 from the left, I'm on the function here, and it looks like the function is approaching 2. But when I'm looking at the right-hand side of it, it looks like the function value is getting close to -2. These aren't the same. This is a +2 and this is a -2. So this limit does not exist. The function value does. When x equals 3, see this closed-in circle? That's what y actually equals. It's an open circle here, does not equal that. It's an open circle here, y does not equal that. This is a closed circle, so y is equal to 1 when x equals 3. The last one I want to look at here is when x approaches 4. So the limit as x approaches 4 of this function. So if this is 3, this is 4 here. So I'm getting close to 4 from this direction. I'm getting close to 4 from this direction. The y value I'm getting close to is 0. So the limit is going to equal 0. And if I want to find the function value when x is 4, it's going to equal 0. The next graph I have to look at has some asymptotes. So that gives us a different way to look at this. And these numbers aren't labeled on here, so I'm just going to assume each one of these is 1. So this would be -1, -3, -5, 1, 3, 5. And then I'm just going to be careful as I count these. The first limit I want to do is x approaches -5. So -5 is right here. What's happening on the left is y is getting increasingly large. It's going down forever. On the right hand side, the function is going up forever. Since these are different, the limit does not exist. The limit as x approaches -1. Here's -1 here. So the limit's coming this direction and this direction. And it looks like, if I look at -1, it's going to that point right there. So that point, the value of that point is 1, 2, 3, 4, 5, 6. Looks to be 6. So the limit as x approaches -1 of this function is going to equal 6. The next integer I'm going to look at is 0. And I don't have to do integers. I'm just doing that to make it easier. So as x gets close to 0, here's 0 for x. The function's coming this way, and it's coming this way. It's coming to the same y value. So that y value looks to be 4. The limit as x approaches 3. Here's 3 right here. So the limit is coming from this direction. Looks like it's getting close to 3 as a y value. Coming from this direction, looks like it's getting close to 3 as a y value. It's a hole, so the value, the function value doesn't exist, but that limit does. And that value is going to be 3. And the last one I'm going to do is the limit as x approaches 6 of this function. So this is 6 here. And when I come down and come across, it looks like it's approaching -1. So the limit as x approaches 6 from the left, x approaches 6 from the right. Looks like the value is going to be about -1, and I'm just going to put these approximately equal to -1 because I'm not 100% sure it's equal to that.